Hello friends, welcome back to our channel Tech India. This is lecture 5th for the series Cloud Computing, and in this video we are going to discuss the topic Representational State Transfer, that is REST. So in this video we will discuss the following topics: Introduction to REST, that is Representational State Transfer, Fundamental Principle of REST, Example of REST in Action, System of System, that is SOS, Example of SOS implementation, Block diagram of systems. Now, introduction to REST, Representational State Transfer. REST is an architectural style commonly used for designing networked application. It provides a set of design rules for creating scalable and flexible web services and APIs. REST emphasizes the use of standard protocol and formats, making it a popular choice for cloud computing and distributed system. So basically REST emphasizes the use of standard protocol and format. So due to that it becomes popular choice for cloud computing and as well as distributed systems. Now fundamental principle of REST. Resource oriented. REST treats every entity as a resource that can be uniquely identified by a URL. These resources can represent data, files, or any other type of information. So basically REST is treating every entity as resource, and the resource could be file, data, or any other information which can be uniquely identified by a URL. Now stateless. Each client request to RESTful API must contain all the necessary information, and the server does not store any client context between requests, ensuring statelessness. Uniform interface. RESTful APIs have a uniform interface utilizing standard HTTP method like GET, POST, PUT, and DELETE, simplifying the design and promoting scalability. Representation. Resource can be represented in different formats like JSON, XML, or HTML, allowing clients to request specific representation based on their requirement. JSON is mostly used in AWS. Self-descriptive messages. RESTful APIs use clear and descriptive messages through the media type to specify the content and format of the representation, enhancing understanding. Now example of REST in action. Consider a cloud service that uses RESTful API. User can interact with the API to perform actions such as uploading, downloading, and deleting files. Each file is represented as a resource with unique URL. For example, you can see here https api.example.com/files/file1. So this is the complete URL for file 1. The API support various HTTP methods like GET, PUT, and DELETE to manage file resources, and it returns file information in a widely used format like JSON. Now systems of system, that is SOS. It refers to a collection of independent systems that collaborate to achieve common goal. So if multiple systems independent to each other are working or collaborating with each other to achieve a common goal, then it is called system of system. Suppose there are few systems like system 1, system 2, system 3, and system 4. If all these are independent, they are working independently, but they want to perform a common task and each of them work together or collaboratively, then it is called system of system. Each system retains its autonomy and purpose, and the communication and the coordination among these systems enable them to handle complex tasks effectively. SOS is commonly used in the context of large-scale application that demands interconnected and distributed functionalities beyond traditional monolithic system. So if application is very large and it needs so many resources and multiple interconnected computers and distributed functionalities, suppose it means like functions are distributed. One task will be performed by this one, another one will be done by this one, then this one, and then this one. Then it will be distributed functionalities and it will be the primary use of SOS. Now block diagram of systems of systems. Here is the block diagram of systems of systems. It is central control system. This is system 1, system 2, system 3. And the block diagram illustrates the structure of systems of systems. Here is the central control system which coordinate and communicate with various subsystems to accomplish the overall goal of systems of system. Each subsystem retains its autonomy and functionality, collaborating with the larger SOS to effectively address complex challenges and achieve the desired objective. So it will retain its autonomy. It will also retain its autonomy and functionality. It will also do its function, and all these three will do the task to meet the requirement or to accomplish the goal of this complete SOS. So this is the purpose of SOS. Now example of SOS implementation. Imagine an intelligent traffic management system that acts as a system of system. It integrates various subsystems including traffic light, surveillance camera, sensors, and a central control system. Each subsystem is responsible for specific tasks such as monitoring traffic, analyzing data, or controlling traffic light. So each of the independent subsystem is doing their own task. They are not interfering in the task of any other subsystem. Cameras are doing their task, sensors are doing their task, and traffic lights are doing their task. So collectively they are making a SOS, that is systems of system. The collaboration among these subsystems enable the systems to optimize traffic flow and respond to the real-time event efficiently. So I hope you got this point. So friends, this was all in this video. Thanks for watching this video. Have a great learning.